Doing a presentation so far has just shown you the basics of pumping performance. We've seen what a pump performance curve looks like, and we've talked about bowl efficiency, and now we're going to see some of those concepts in real time. Bill is going to operate the pumps and this control valve that modifies the flow rate through our system. I'll be over here with the display and this pointer explaining what you're seeing, which is a graphic depiction of the actual operation of these pumps' performance. Bill? Now as the pump starts up, you're going to see these crosshairs. And these crosshairs are showing the combination of flow and total dynamic head that this pump is operating at. As you can see, we've started the pump with the valve pretty much open. And our operating condition is down here on this part of the curve. Now I'm going to put a set point on there so we can save that. Now Bill's going to close the valve down a little bit, and we're going to move up the curve with our pump. And you can see these crosshairs start to move. I'm closing down my valve, so I'm closing down the flow. I'm increasing the pressure. Going to let the system stabilize a bit. Put another set point. Bill's going to close the valve further. You can hear the different tone of the water moving through the system as it has to work harder and harder. We're going up to the top of our curve. So now we're down at a very low flow, high pressure. We'll mark that spot. Now Bill, open up that valve and get rid of the noise. So as you can see, as we close this valve down and ran our pump up and down the performance curve, just like the manufacturer told us. As we've said, a pump can put out a lot of water at a relatively low pressure, like here, or relatively low flow at a very high pressure. Now, the key issue though is that it will do these different operating conditions at different efficiencies. And what I've added right here with these lines and these numbers are the bowl efficiencies of this pump at the various operating conditions. You can see at this area right here, it'd be operating about 60% on the bowl. In this area, 78%. Now, we're back down here at this point. You can see we're way below our optimum efficiency. The efficiency is 33%. This pump right now is costing $15.30 an acre foot to pump water. If I had an optimum pump, $8.60, roughly half. Okay, Bill, let's go up into our high efficiency. Now I'm moving up into where our highest efficiency is. You can see that the overall pump efficiency is 60%. That's because I have a motor involved. Look at the cost. Our pump is costing $24.30 an acre foot. The optimum pump is about the same because we are operating this pump where we want to. Now if I close that valve down further, now we're going to move back up a little bit more. My OPE has gone down again, 50%. I'm costing $36.50 an acre foot. My optimum pump would only be $31. The basic lesson here is if I needed a pump that pumped 100 gallons per minute at about 95 feet ahead, this is the pump I would use because it's efficient at that point. If I had to pump 150 gallons at 20 feet ahead, I would not use this pump. And so the basic concept of pumping performance is to know the required operating condition and choose the pump that's best for that condition.